Hello everyone. In this short video we're going to talk about arc length and surface of revolution, the area of a surface of revolution for polar graphs. If you remember in previous chapters when we talk about arc length, we did discuss that arc is consist of infinitely many line segments, and in order to find the arc length I have to find the distance of one of these line segments, then I add them up together to get the total arc length. If I consider this one my first point, and if I consider this one my second point, therefore the change in x is here, which is x2 minus x1. The change in y is here. This is a right triangle, and the line segment is the length of the hypotenuse. Therefore that would become the square root of a squared plus b squared. And in order to find the sum of all that, I have to use integration. But in here I have two options. I have to integrate with respect to x or respect to y. If I do it with respect to x, therefore my x is going to go from a to b, but I do need a dx here, which I don't. But I have an option, multiply the top and bottom by dx. But I only require the dx on the top. What am I going to do with the x on the bottom? I'm going to move that dx in the bottom right here by making it a square, because it's under radical. The square root of dx squared is dx, and I remove that one. Then what I see inside here, I see change in x over the change in x squared, both power of 2, let's make it 1. And this is the change in y over the change in x, change in y over change in x, called derivative. Therefore that answer is going to become 1 plus y prime squared dx when x is from a to b, and that's finding the arc length by making the x fixed. But somebody said, I don't want it with respect to x. I want to do it with respect to y. Therefore, you have to say y is equal to c and y is equal to d. But I need a dy here. But I don't need this y. I move the dy inside. Therefore, that becomes dy squared over dy squared, which is 1. But this is dx dy is a derivative of x respect to y. Therefore, you say you call it c to d square root of 1 plus x prime squared dy. That's a arc length when you're trying to do it respect to y. But somebody said maybe the x and y are in parametric function and both are dependent on t. I don't need dy dy, but I need dt. I said that's okay, you multiply by dt over dt and move that dt over here, and that become t equal to a to t equal to b, but under radical is change in x over the change in t square, and this is the change in y over the change in t squared dt. That is the arc length in parametric form. But somebody said I'm moving to polar. Polar, everything is function of theta. I don't need any of them. I need d theta. I said that's fine. You multiply the top and bottom by d theta and move that d theta inside, and that's become d theta squared. Then in polar it becomes theta is equal to alpha theta 1, and theta equal to beta. Alpha must be less than beta, and that become dx over d theta square plus dy over d theta square d theta. It's not very hard to find the arc length in any format you like. But when it comes to parametric function, your x is a function of r and a theta. But this has to be function of theta only. and y is also r sine theta. But remember, this is a general form to represent to represent x and y for any r. Somebody said, what happens if my r become a circle? Therefore, you have to replace that r by cosine theta and replace this r by cosine. What happens if I'm talking about the arc length of a cardioid, like 2 plus 2 cosine theta? That r has to become 2 plus 2 cosine, and this r have to be r plus 2 cosine. Therefore, your x is r, which is a function of theta, times cosine theta. And your y is also eventually going to be function of theta and sine theta. And we're going to do exactly what we did with the derivative. What did we did with the derivative? We said dy d theta. Therefore, we copy the first time derivative of a second plus copy the second time derivative of the first over this one. We copy the first time derivative of the second plus copy the second time derivative of the first. Therefore, this one is dy d theta, this is dx d theta. For the arc length, I need to square both of them. Therefore, what is dx d theta square? Is all of this square. If you square a negative, it becomes a positive, and it becomes f of t squared sine squared theta. You got to multiply these two because I'm doing FOIL outside and inside. That becomes negative 2 because positive times negative is a negative. F of theta, f prime of theta, sine theta, cosine theta, plus the next one is f prime theta squared, cosine squared theta, plus dy d theta squared, because that's what the arc length shows. Therefore, in here for dy, which is on the top, you have f of theta squared, cosine squared theta, positive times positive is positive, 2 f of theta, f prime of theta, sine theta, cosine theta, plus f prime of theta squared, sine squared theta. These two we have added together. Well, this is a plus, this is a minus, this goes away. But this one, they have f of theta squared as a common factor, and what I see here is sine squared plus cosine squared, which is 1. In here, I have f prime of theta squared, and when I say as a common factor, you said cosine squared plus sine squared is 1. Therefore, from today, you have to know the arc length in the polar is r squared plus r prime squared d theta. But remember, that's a general form. It depends on your polar function. R is going to be different. I'm going to choose r equal to 2, let me think, plus 2 sine of theta. I'm going to do the cardioid. Let me think what the graph of cardioid look like. When the theta is 0, sine of 0 is 0, I only have a 2. When this become pi over 6, sine of pi over 6 is 1/2, 1/2 times 2 is 2, 2 plus 1, 1 plus 2 is a 3. Therefore, from pi over 6, it get larger. When this become pi over 2 is 1, 1 times 2 is 2, 2 plus 2 is a 4. It get larger. Therefore, my graph so far is like this. But if this become 180 degree, the sine is 0, you have only 2. Therefore, remember, this one, your r was 2, your angle was 0. Here, your r is 2, your angle is pi. Here, your r is 4, your angle is pi over 2. But what happens if it's 3 pi over 2? Sine of 3 pi over 2 is 0. Sine of 3 power 2 is negative 1. Negative 1 times 2 is negative 2. Negative 2 plus 2 is 0. Therefore, this one is 0 and 3 power 2. And from there, you go back to 2 and 2 pi. If you want to find the arc length, you know at this point you have a cusp. Therefore, I know this point and this portion and that portion are symmetric with respect to the line of theta equal to power 2. Somebody said, can I find the arc length from power 2 to 3 power 2 and double it? Yes. But what happens if I do this side? You cannot go from 3 power 2 because after 3 power 2 is 2 pi. After 2 pi is 5 power 2. It had to be less than, and therefore I'm going to use a negative angle. Therefore, this is the same as 0 and negative power 2. Therefore, in here, I'm going to go from negative power 2 to power 2 and double it. And this one should be from alpha to beta. Therefore, your arc length is r squared. Square that one for me. Is 4 plus 2 times 2 is 4. 4 times 2 is 8 plus square that one is 4 sine squared theta. But what is the r prime? R prime is 2 cosine. And when I square the 2 cosine, I get 4 cosine squared theta d theta. What I see right here is 4 a common factor. And inside I see sine squared plus cosine squared, which is 1. And what is 4 plus 4? I get 8. And what is 8 plus sine of theta? I factor the 8 and I'm going to pull it out, and that becomes 1 plus sine of theta d theta to negative power 2 to power 2. And that's your arc length. The issue here is I have to make this one integrable. Am I going to do u substitution? I cannot do it because the derivative of a sine is cosine. I don't have it. Trig substitution, trig within the trig, maybe it's hard. Let me see if I can make some kind of an identity. I'm going to give you some hint. If you remember 1/2 plus 1/2 cosine 2 theta was cosine square theta. These are called double angle identity. But if I get a common denominator and bring the 2 here, that becomes 2 cosine square, and that becomes 1 plus cosine 2 theta. Remember the relationship between these are half. Whatever this one is, this becomes half. If I make this one a theta, that becomes a theta over 2. If it was 1 plus cosine square, I could put 2 cosine square theta. If it was 1 minus cosine square theta, I could put 2 sine square of theta over 2. Because these are the double angle identity. But unfortunately, this is 1 plus sine. Since I don't have any identity for it, I'm going to do something that makes this become a perfect square. And what I can do to make it a perfect square, I multiply it by its conjugate. When I multiply by a conjugate, it becomes 1 minus sine square, and 1 minus sine square is cosine square. Therefore, but I got to divide it by 1 minus sine theta. Right now on the top, you have cosine squared theta. On the bottom is 1 minus sine theta. But that's the perfect square. You write cosine theta over the square root of 1 minus sine theta d theta, and the square root of 8 is 4 times 2. Square root of 4 is 2. 2 times 2 is 4. That's 4 radical 2 from negative power 2 to power 2. But somebody said, how do I do this? This is easy. Because 1 minus sine theta is your u. Your du is 0 minus cosine theta d theta. And I do have cosine theta d theta. I just don't have a negative. I put a negative here and I put a negative here. Therefore, this problem becomes du over u to the power of 1/2. I'm not going to change the limit of integration. Therefore, I'm going to integrate this and then write it back into a term of theta, and I use the same limit of integration. That becomes u to the power of negative 1/2 du, and that becomes u to the power of negative 1/2 plus 1 is 1/2 times 2 over 1, and that's the same as 2 square root of 1 minus sine theta. Therefore, I have a negative 4 radical 2 times the 2, and I have 1 minus sine theta, and I integrate it from negative power over 2 to power over 2. This is negative 8 radical 2. When I put power over 2 right here, sine of power over 2 is 1. 1 minus 1 is 0. But sine of negative power over 2, that's the odd function, and you move the negative out, and the answer to become a negative 1. Therefore, that's become negative 1 times negative is a positive, that become minus the square root of 2. And that answer become square root of 2 times square root of 2 is a square root of 4, and become 2, and it becomes 16 u. U means unit, because that's your arc length. And that's how you find your arc length in a polar function. But sometimes somebody gonna say, what happens if I take 2 plus 2 cosine theta, which is your r? This is the graph of a cardioid. When the theta is 0, my r is 4. And when the theta is pi over 2, my r is 2. When the theta is pi, my r is 0. Therefore, that's the graph of a cardioid. But that's only half of it. And this is nothing except from 0 to pi. I'm going to take this half and revolve it around the polar axis. But for a minute, I want you to put xy plane here. Say this is x, this is y. And instead of saying revolving around the polar axis, let's revolve around the x-axis. When you revolve around the x-axis, you get nothing except a solid. You get a solid right here. This is nothing except your heart. And I want to find the surface area. What I'm going to do, I go inside here. I'm going to cut a small cylinder out of it. A small cylinder out of it. And that cylinder become like this. Therefore, what is the volume? The volume is going to become cylinder. The volume is just like a the surface area is like a square. You fold the square or rectangle, it becomes a cylinder. Therefore, when I open it, this length is a circumference. Therefore, it's circumference times the height. This is the surface area. Okay. In here, what is your height in here? Your height is part of the curve. Therefore, your height is a part of the arc. What is your r? If you do it respect to a polar axis, your radius is a y. And 2 pi, and that's the surface area. But somebody said, what is y? Y is r sine theta ds. This is a surface area of one of the cross section. What do you do with this? You go and sum it up from 0 to pi, 2 pi, r sine theta, and arc length is r squared plus r prime squared d theta. This is called the surface area of the solid if you do it about the polar axis. Somebody said, what happens if I take that graph, which is r equal to sine theta, and revolve around the line of theta equal to pi over 2, I'm going to get a sphere. You remember your radius right here, because that's the radius of revolution, is x. Therefore, about the ln of theta equal to pi over 2, your surface area is going to become alpha through beta 2 pi, but your r is x. X is r cosine theta square root of r squared plus r prime squared d theta. Therefore, these are the two formula you should know for surface area. About the polar axis, about the line of theta over 2. Somebody said, can I do this one about the line of x equal to 5? Yes, but we're not going to do it in this textbook. Therefore, somebody said, what is the surface area right here? Remember, I went from 0 to pi. I had a 2 pi. My r is a cardioid. Therefore, when I say 2 pi r is 2 plus 2 cosine theta, that's your r only, times sine theta times the arc length. But what is your arc length? Your arc length is r squared. Your r squared is 4 plus 8 cosine theta plus 4 cosine squared theta. R prime is negative 2 sine theta. When you square a negative 2, it becomes positive sine squared theta d theta. Therefore, this is right now my surface area. Then let's find that surface area and see what the answer is. The surface area is 2 pi 2 times sine theta. I'm going to write this one as the sum of two integral. Then I'm going to come back, do the 2 sine cosine. And I'm going to integrate. This one is for a common factor. Common factor. Therefore, that becomes 4 times 1. 4 plus 4 is 8. 8 is a common factor, which is 1 plus cosine theta d theta. That's only the first. Plus, the next portion is 2 cosine theta sine theta times same thing, 8, 1 plus cosine theta d theta. How do we do this? First of all, if I make this, this is the square root of 8. The square root of 8 is 2 radical 2. 2 radical 2 times 2 is 4 radical 2 times 2 is 8 radical 2. Therefore, I have 8 square root of 2 pi, and I have sine theta square root of 1 plus cosine theta d theta. That's very easy because this is your u, that's your du. Okay, let me go ahead and solve that one. If 1 plus cosine theta is your u, your du is negative sine theta d theta. I don't have a negative. I put a negative here and I put a negative here. And this is from 0 to pi. Then I'm going to say I have negative 8 square root of 2 pi. Therefore, this becomes du and that becomes u. U to the power of 1/2. When I integrate it, it becomes u to the power of 3/2 times 2/3. And u to the power of 3/2 is 1 plus cosine theta to the power of 3/2 from 0 to pi. What is cosine of pi? Negative 1. Negative 1 plus 1 is a 0. Therefore, the first part is 0. Minus. What is cosine of theta? Is 0. 1. 1 plus 1. 2. 2 to the power of 3/2. Therefore, I have a 2/3 here, and I have a 2 to the power of 3/2. What is negative times negative? Is a positive. What is 2 times 8? Is 16 over 3 pi times 2 to the power of 3/2. And I hope I didn't make any arithmetic mistake, but that's a positive number. I accept it. The process, it looks right. But what am I going to do with this? Well, if I make 1 plus cosine theta to become a u, I know cosine theta is u minus a 1. And I know the differential And what is the d theta? My d theta here, I have to do it. What is the d? What is my, let me see, what is my du here? My du here is negative sine theta d theta. I know what is my cosine of theta. I know what is 1 plus cosine theta. I know what is cosine of theta, and I know this is a du. Therefore, I go in here and I go from 0 to pi. Let me take care of everything. I have a 2 here. Instead of negative sine theta d theta, I'm going to put du. I have a sine, I have a d theta, but I don't have a negative. I'm going to put a negative here and negative outside, therefore that's become a negative. Instead of negative sine theta d theta, I'm going to put du. Therefore, I'm going to take the limit of integration because these all belong to theta. Instead of a cosine, I'm going to put u minus a 1. And instead of 1 plus cosine, I put u. Therefore, I'm going to pull the 2 out, and I'm going to say the integral is u to the power of 3/2 minus u to the power of 1/2 du. When I integrate it, is u to the power of 5/2, 2/5, minus u to the power of 3/2 times 2/3, and I do have a negative 2 here. I'm going to change my u back to 1 plus cosine theta to the power of 5/2 minus 2/3 of 1 plus cosine theta to the power of 3/2, and I go from 0 to pi. If I put cosine of pi is negative 1, that's the 0, that's the 0. Therefore, I have a negative 2, 0 minus. When I put 0, cosine of 0 is 1. Therefore, I have 2/5. 1 plus 1 is 2. 2 to the power of 5/2. Minus 2/3. When I put 0, cosine of 0 is 1. 1 plus 1 is 2. 2 to the power of 3/2. And both of them have negative as a common factor. Negative times negative is a positive. Therefore, what I have here is 4/5 times u to the power, 2 to the power of 5/2 plus 4/3 2 to the power of 3/2. I'm sure you're going to put in the calculator and you're going to say the surface area is 4/5. I'm going to not write 4/5. I'm going to write 2 to the power of 3/2 as a 2 to the power of 3/2 as a common factor, because I have to add these together. From here, what I have left is 4/5 of u to the power of 1, which is 2 right now, plus I factor u to the power of 2/3, I have 4/3, and when I factor u to the power of 3/2, I have plus 16 pi over 3. I have an issue because in here I had a pi. I did apply the 2 pi on the first one, but that 2 pi should be carries. That also should have a 2 pi. That should also 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 have a 2 pi. This has to have a 2 pi. Therefore, I need a 2 pi here. Therefore, in here, I have 2 pi. Okay, there is a 2 pi, a common factor. 2 pi, 2 to the power of 2/3. From that one is 4/5, u to the power of 2 to the power of 1, 4/3, u to 2 to the, and then this one is already factored. Here I took the 2 pi out. That become 8/3, and that's become it, because that's the factor. 8/3 and 4/3 is 12/3. 12/3 is 4, and that's 8/5. 8/5 plus 25th, because this is a 4, let's make it 28/5. Therefore, your surface area is 2 pi times 2 to the power of 3/2 times 28/5. You want to simplify this a little bit, you're going to say 56 pi over 5 times 2 to the power of 3/2. Sorry for the mess, but that is a surface area. That was not an easy problem, but that's the surface area. Is it doable? Yes, it's doable. We got to learn how to do those problems. I'm going to get a quick problem right here. Remember, this is called SR equal to a theta. This is called identity function. When theta is 0, R is 0. Theta is 1, R is 1. Theta is power 2, R is power 2. Therefore, when I go to the pole and say when theta is 0, R is 0. When theta is power 6, R is power 6. And when the theta is power 2, you have power 2 and power 2. And this becomes a curve. This is called Archimedean curve, like a spiral. But I only need it up to that part, from 0 to 2 pi. And I'm going to revolve it around the what? Around the polar axis. The line of theta equal to power 2. And my radius is x. Therefore, your surface area is from 0 to pi over 2. 2 pi. Your r is x, which is r cosine theta. And what is your r squared? Is theta squared. And what is the derivative of r respect to theta? What is the derivative of theta respect to theta? Because this is dr d theta is 1. Therefore, I'm going to become 1 square. R squared plus r prime squared. And that's become a d theta. Then, here I made a mistake right here. Because, oh no, that's right. This is r cosine theta. This is x. X is r cosine theta. Everything looks right. Therefore, I have a 2 pi. But what was that r cosine theta? Your r is theta. You have 0 to power 2. You have theta. You have theta squared plus 1. And you have cosine theta, d theta. Okay. Therefore, this is the surface of revolution. Is it possible I can solve this problem? How can I integrate it? Well, the question is here, the only thing I can do this one is the integration by part. I don't see any other way to do it. Because integration by part, I can integrate this, and here I can differentiate it. Then, or I can integrate, and then I have to do integration by part. Therefore, I'm going to use a graphing calculator, see if this one is doable by a graphing calculator. I don't think graphing calculator is going to allow us to find the surface area right here. Therefore, if I go to y equal to, and if I go right here as theta square root of theta squared plus 1, and outside I have cosine theta, then I'm going to multiply by 2 pi again. If I go to my matrix, if I go to math and put chapter 9, everything respect to, let me see what happened. I put 0, never done it before, pi divided by 2, but in here I go to variable, y variable, I'm in the polar. I put R1, and I do respect to a theta. Look at what does it give you. Therefore, you can do integration using your graphing calculator, and that's 0.754. But you gotta multiply this one, multiply by 2, and by 2 is 1.805. Therefore, your surface area here is 1.51 pi, and that's the unit square. That was a great lesson to help you to do your calculator to find the integration of the polar coordinate, and that's something I was going to teach, and I got it very successful at it. Therefore, in here, if you want to do it, you have to say my u is cosine theta, my du is negative sine theta d theta, this is my dv, which is theta, the square root of theta squared plus 1 d theta. Then you have to find your v, then you have to continue doing it to use integration by part. But at this moment, you're not going to do a lot of this stuff in polar coordinate. If it's a hard one, you can use a graphing calculator. But if something the faculty said show work, you have no choice to do every one of these paper and pencil, because this is doable. Thank you.